In order to replace the loading on the frame by a single resultant force and specify its location on the member CD measured from point C, we can start by first calculating the resultant force component along the x and y direction. So to start, our 250 Newton is acting at an angle given by the right angle triangle of 3, 4, 5. We can calculate its x component by multiplying it with 4 over 5. Here, since the 4 is parallel to the x-axis, that's why it's in the numerator divided by the hypotenuse of the right angle triangle. This will give us the component along the x-axis. Now, since it is going towards the left, that's why it's taken as negative. Whereas our 300 Newton force is acting vertically downward, it doesn't have the x component. Finally, our 500 Newton force is making an angle of 60 degrees with respect to the x-axis. So taking the cos 60 function will give us the x component. Again, this component is going towards the left, that's why taken as negative. Combining them together, we get our resultant force component along the x direction as negative 450 Newton. Next, let's go ahead and add up all the y component forces. So to start, our 250 Newton is also acting at an angle. We can calculate its y component by multiplying 250 with, this time, 3 over 5, as 3 is parallel to the y-axis. This will give us the y component. Next, we have our 300 Newton force that is also acting downward. Since both of them are acting downwards, that's why they are taken as negative. Finally, our 500 Newton force component can be calculated by taking the sine 60 function that is also going to project it vertically downward. Adding them all together, we get our resultant force component along the y direction as negative 883 newtons. Now, once we have both the component, let's go ahead and identify the magnitude of the resultant force by combining x and y component, utilizing our formula of the magnitude, that is square root of the x component is square plus y component is square. If we simplify, we are getting our final value of 991 Newton. Now, once we have the magnitude, we also have to identify the direction at which this force is acting. So, utilizing our tangent inverse function, by taking the tangent inverse of the y component's magnitude divided by the x component magnitude. In this case, remember, we are just taking the magnitude and we are not talking about the directions here. This gives us an angle of 63. Now, for the negative signs that were present there, that tell us in which specific quadrant that force is acting. Since both of them were negative, that's why force is acting in the third quadrant, and the angle 63 is measured from the negative x-axis. Next, we can go ahead and represent our force and its component on the beam in order to identify its position with respect to point C. So let's go ahead and identify that position x. To do that, we will utilize our summation of moment formula. That is the summation of moment of the resultant force component at point C will be equal to the summation of moment of all the individual loadings as point C. So to apply, let's look at the resultant force first. Since our 450 Newton is acting in the line of action of C, it won't have any turning effect. It is just going to push the point C, whereas 883 is vertically acting, so it has a moment arm of X with respect to point C, and it's going to create our clockwise moment. Next, let's go ahead and look at the individual moment components. So in this case, we are given an external coupled moment of 400 Newton meter that is acting in the counterclockwise direction. That's why we have represented it as a negative sign. Next, I have that 300 Newton force. Again, the moment arm of that is 3 meters. As it is acting vertically downward, it is going to create our clockwise moment. That's why taken as positive. Next, for the 250 Newton, the x component of it won't create any moment since it's passing through the point, whereas the y component of it is going to create our clockwise movement with a moment arm of 6. Finally, we have our 500 Newton force. Again, for the x component in this case, since it is acting horizontally with a moment arm of 2, that is in the vertical direction, it is creating our clockwise movement, whereas the vertical component of 500 sine 60 with a moment arm of 1, it's going to create our clockwise movement as well. Adding them all together and simplifying, we get our value of x as 2.64 meters.